Assalamualaikum. Hi guys, welcome back to my YouTube channel. My name is Dea Febriana. I'm from the study of program Chemistry, the Faculty of Science and Technology, the Islamic State of Raden Patah, Palembang. I am from Group 17, course Physical Chemistry and Lectures Jauharuddin Lutfil Jaber MSI. Okay guys, in video, I want to explain material about activities and reaction equilibrium, activities in electrolytic solution, the Debye-Hackel theory of the structure of dilute ionic solution, and equilibrium in ionic solution. Okay guys, before you're watching in video, please don't forget like, comment, and subscribe. Thank you guys. Come on. Activities and reaction equilibrium. If a chemical reaction takes place in a non-ideal solution, the chemical potential in the form given must be used in the equation of reaction equilibrium. The particle system is more commonly used. The condition of equilibrium becomes delta G equal mean RT ln Ka, where delta G is the standard Gibbs energy change and Ka is the proper equation of equilibrium activities. Since delta G is a function only of T and ρ, Ka is a function only of T and ρ, and is independent of the composition. Since its activity has the form Ka equal Kym, where Ka and Km are proper quotients of activity coefficient and of molarities, respectively, since the Ys depend on composition, so that Km depends on composition. In the light real solution of the Ys approach unity, Ky approaches unity, and Km approaches Ka, except when we are particularly interested in the evaluation of activity coefficient. We shall treat Km as if it were independent of composition. Doing so greatly simplifies the discussion of equilibria. In most elementary treatment of equilibrium in solution, the equilibrium constant is usually written as a quotient of equilibrium concentration, expressed as molarity. Ka means it is possible to develop an entire system of activities and activity coefficient using molar rather than mole concentration. We could write A equal YC, where C is the molar concentration and YC the corresponding activity coefficient. Activities in electrolytic solution. The problem of defining activities is somewhat more complicated in electrolytic solution than in solution of non-electrolysis. Solution of strong electrolysis exhibit marked deviation from ideal behavior, even at concentration well below those at which a solution of a non-electrolyte would behave in the ideal delight way. The determination of activities and activity coefficient has a correspondingly greater importance for solution of strong electrolytes. To simplify the notation as much as possible, a subscript as will be used for the properties of the solvent. Symbol without subscript revert to the solute. Subscript plus and minus refer to properties of the positive and negative ions. The D by Haeckel theory of the structure of delight ionic solution. At this stage, it is worthwhile to describe the constitution of ionic solution in some detail. The solute in delight solution of non-electrolytes is adequately described thermodynamically by the equation. The chemical potential is a sum of two terms is fairly good for most non-electrolytes up to concentration as high as 0,1 m, and for many other it does well at even higher concentration. The simple expression is not adequate for electrolytic solution. Deviations are pronounced even at concentration of 0,001 m. This is true even of is modified to take into account the several ions produced. The extra Gibbs energy represented by the term VRT ln Y plus minus is mainly the result of the energy of interaction of the electrical charge on the ions. Since in 1 mole of the electrolyte there are V and A ions. This interaction energy is, on the average, kT ln Y plus minus per ion, where the Boltzmann constant K equal R per Na. The van der Waals force acting between neutral particles of solvent and not electrolyte are weak and are effective only over very short distance, while the Coulombic force that acts between ions and thus between ions and neutral molecules of solvent are much stronger and act over greater distance. This difference in range of action accounts for the lag deviation from ideality in ionic solution, even at high dilution where the ions are far apart. Our object is to calculate this electrical contribution to the Gibbs energy. The Gibbs energy of an ion is greater than that of a neutral particle by W. This additional energy is made up of two contributions, W equal Ws plus Wi minus. The energy required, the charged and isolated sphere immersed in a dielectric medium, is the self-energy of the charged sphere Ws minus since W does not depend on the concentration of the ions. It will be absorbed in the volume. The additional energy beyond Ws needed to change the ion in the presence of all the other ions is the interaction energy Ws plus whose value depends very much on the concentration of the ions. It is Wi which we identify with the term equilibria in ionic solution. From the Debye-Hackel limiting law, we find a negative value of in y plus minus, which confirms the physical argument that the interaction with other ions lower the Gibbs energy of an ion in an electrolytic solution. The lower Gibbs energy means that the ion is more stable in solution than it would be if it were not churned. The extra stability is measured by the term Kt ln y plus minus in the expression for the chemical potential. Now we examine the consequences of the extra stability into simple case, the ionization of a weak acid and the solubility of a sparingly soluble salt. Consider the dissociation equilibrium of a weak acid Ha equal Ha so Ha plus A minus. The equilibrium constant is the question of the activist. K equal AH plus AA minus divided A. By definition, we are AH plus equal Y plus NH plus AA minus Y minus MA. AHA equal YHA MHA. So that K equal Y plus Y minus divided YHA times MH plus MA minus divided MHA equal Y2 plus minus divided YHA times MH plus MA minus divided MHA, where we have used the relation Y plus Y minus equal Y2 plus minus. If the total molality of the acid is M and the degree of dissociation is X, MH plus equal XM, MA plus equal XM, MHA equal 1 minus X times M. Okay guys, thank you for watching until the end. Please don't forget like, comment, and subscribe. And I hope you can understand what I'm saying. Sorry if in my delivery there are wrong because I'm still learning. Please understand. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.